Yeah, in Power BI we used a data set, of course, but in Python for a lot of things you did not need a data set. You could, I mean, it was not always about only data, working with um, tables and everything. But in SQL, what we will do is we have to work with tables, properly structured data sets only. SQL works with only structured databases. Now, why am I calling it a database and not just a data set, like how I did with Python and Power BI is? Because database is a place where you store multiple data sets, where you store probably a lot of data, and you can say storing multiple tables at one place. So there will be many tables in that particular database, and this has to be structured. What do I mean by structured database? Structured databases are cleaned databases where there are no errors in it. Now, I would use Python to clean the databases. I would data sets. I would use Power BI Power Query Editor to clean the data sets. That is, remove any errors or any duplicate values, replace values, all those things I would do. But in this case, in SQL, when we move the data into SQL, it will always be structured. How does that happen? A lot of times when the data is extracted, there is a process called as ETL. Data is extracted, transformed, and then loaded into databases. Okay, so before this structured databases are created, this is the process. And this is performed by, I mean, these are not performed by data analysts mostly. These are, there will be some ETL developers, data engineers who would do that. Okay, so if you're working as a data engineer, now the data can come from multiple sources. This data can be coming from a different database. A lot of companies do this. There is a process called as data migration, that from one database they want to move their data into another database. Now that is could be from where the data is extracted, or data could be extracted from a website, from an application, anywhere. And then the data is transformed, like exactly what we did using Power Query Editor. All the processes, all the steps, exploring the data and then cleaning it. After we clean the data, we will load it into a database. So after this step, that is where your SQL comes into picture. SQL is, however, a language, but let's say this is stored into a database after that. In database also there are two types. There is a relational database and there's a non-relational database. Relational database is where all the tables are related to each other. For example, if I have these three tables, I have these three tables. I have customers table, orders table, and products table. Okay, so I think I've used this example before, but you'll be able to understand it when you look at it. You see the common column between the tables, right? Between customers and orders, I have a common column. Between orders and products, I have a common column. So when I'm saying common column, let's not just remember it like the same column available in both tables. Let's not remember it only like that. So just know that when we receive, let's say you are running some business and you receive some order. So when you receive those orders, they would be from the customer in your database only. Or let's say even if the customer is not in the database, the customer would have to register, right? The customer would have to register on the website. So when they register, the data will be added to your database. And those customers only are placing the orders. And what products are they placing the order for? Which are again in your database. So that is why all these three tables are related. So obviously, when I look at this, in this I have only customers information. Here I have only products information, And here I have only orders information. So if you remember, we did dimension and fact tables. So these two are dimension tables, and your orders is a fact table. And both all the three of them are related. Customers place the orders for the products that are available again in the table. Because there are common column in between these tables, and they are related to each other with this is called as a relational database. There could be normal non-relational databases also. Why are they? So what will happen in case of a non-relational database? You will just have one table there, just one table. And in this only you could have the scores of the students and the course they have pursued, everything in the same table. You will not have them all separately. This type of a table or this type of a database is called as non-relational. Can you work in SQL with non-relational database? Yes, you can work with it. Okay. If the table is just if it's only one table also, you can still work with that particular database. There will be different ways to load, and in SQL also, when you're using, again, you can load the tables, you can load the entire database at once, you can load different CSV files, Excel files, and you can also directly connect to an app's API. Have you ever heard about API? Do you know what's an API?
Yes.
Right. So you can directly connect it to an app's API. That is used when API keys and APIs are used when you want to access data of a particular application. So if you look at this LMS, there will be an API and its key. That if I want to access the backend data, I'll be able to access it if I have the API key for this. So the data will directly be taken from that application rather than creating different CSV files and everything. So you can directly connect, that can be different data sources. So this was mostly about the data set, databases and all that. But then um, where does SQL come into picture? So let's say when I have a lot of questions about this data, like maybe I want to explore it more, right? It's mostly data analysis that we do with SQL. So let's say if I want to find out which customer placed orders, um, most number of orders, okay, which customers placed most number of orders. So based on this, I can look at each table and I can find that data out, find that answer out. So what am I doing? Asking questions to the database. And when I ask questions to the database, I cannot ask the database in English because, of course, the database won't understand this language. So, a language that these databases would understand, structured query language, is one of them. That is when SQL comes into picture. Okay, structured query language is one of them. Now, SQL is the simplest of all the language. It's not a programming language, it's a querying language. Programming language would be Python, where you are able to build something, right? But in case of SQL, you're asking questions to the data and you're getting your answers here. How does SQL run? Where does it run? Every application will have a database at the backend. For example, even if I open Amazon, anything that I search here, there will be a query that will be running in the backend when I just write it. If I want to purchase probably a book, right? So in the backend, probably the query will be select star from product where product is equal to book. So the entire query will be written over there. So a query will be running in the backend. So SQL is a backend language. It will be running on the databases. It will help you fetch data from different databases, and this will be working in most of the applications. Okay, but what again, when I just search about SQL, there are a lot of things that come into picture. As soon as I search for SQL, I'll find MySQL. I'll find something like PostgreSQL. I'll also find something called as NoSQL, and so on. There can be many. So MS SQL Server is also one of them. And there are so many of these. Now, what is the difference between each of them? How is SQL different from all of these? About NoSQL, I'll tell you in a while. But about all of these, MySQL, PostgreSQL, MS SQL Server, SQL is if SQL is the language, these are the tools that you use to interact with this data. Now when I'm interacting with you, I need a tool. I'm connecting with you through the LMS, right? The application that I have, I'm connecting to you with that. When you speak to others, somebody who's far away, you speak to them on a phone. That is also can be a very good example for these. You need some tool to speak, you need some tool to use, write these SQL queries. Like just how you need to that phone to speak to different people, here you need these tools to speak to your data. So MySQL, PostgreSQL, MS SQL Server, how are they different? All of them are doing the same thing. But how are they different? They differ based on the companies that provide them. For example, MS SQL Server is provided by Microsoft. MySQL is by Oracle. PostgreSQL, I don't remember. But then with all these different companies, they'll be providing a lot of them. There is something called as Azure SQL also, that is also from Microsoft, and so on. Also, we will be learning through MySQL, okay, because it's the simplest, it's open source, you can use it. Same goes with PostgreSQL, MS SQL also, but we will go ahead with MySQL when we go ahead. For now, you don't have to download anything, but I'll tell you when do you have to. So in case of MySQL, yeah, let's say you have learned on MySQL, does that mean you cannot work on these? It's not the case. The queries are going to be the same for all of them. There will be a few here and there things that would be there, a few queries that can differ, a little bit of interface change, all those things that you just need to get used to. But otherwise, all the basic queries are going to be the same. When they interview you for SQL, they will never ask you whether you know MySQL, PostgreSQL, and all that. They'll just ask you questions on different queries, on MySQL queries only. They'll judge you based on their on the language, on the use of SQL. How are you able to use the queries? So these are all that you can add in your resume if you just learn the language SQL. So we're learning SQL as a language, not these as a tools. Then you have NoSQL. Okay, NoSQL will be working on unstructured databases. When I told you SQL is used for only structured databases, that is properly clean databases, then what do you do with unstructured databases? You usually clean them. The best way is using ETL processes, it is cleaned. The data is cleaned and then moved to a database and used. But most companies, see, if there is a project that is running, 70% of that project time will go for data cleaning only. Okay, 70% of the time would go for data cleaning. But to avoid that one step, companies chose to use that unstructured database directly. And when they do it, they cannot use SQL for that. They use an entirely different language, it's called as NoSQL. In case of data science, data analysis, machine learning, you don't use NoSQL. You will always use SQL in these cases because you need clean databases. You're going to make business decisions based on this. So your data sets need to be clean. In case of NoSQL, it is always unstructured, and NoSQL is mostly used for for these development, full stack development. Have you ever heard about MERN stack development? In this MERN stack development, you use something called as MongoDB. MongoDB is one of the examples of NoSQL databases. Like for SQL databases, you're using these, right? For NoSQL, you would use MongoDB. but these are mostly used in case of development, app development, web development, full stack development, whatever you want to call it. Okay, but here SQL is mostly used for structured data only, and we will be focusing on working with structured data. All right, is it clear till here? Were you both able to understand these basics?
Yes, yes,
Okay, all right. Now as we go ahead, in SQL is again divided into different parts. Like if I talk about the English language, based on the use of the language, where are you using it, how are you using it, it's divided into different parts of speech. You have nouns, you have pronouns, you have verbs, based on how you're using it. Similarly, SQL is also divided into different parts based on its use. So let's first understand the use of SQL. It can help in creating databases. It can help in updating the database. If there are any changes, creating database could be, example for creating database could be, let's say I'm establishing a new business. In that business, I would get a lot of customers. I would have a lot of employees. I would have different products that I'm selling. So all that I need to add in a database. So this time I'm not extracting data from somewhere, but I'm creating it myself because it's something new that is being established. So creating databases I can do in SQL. And then let's say for some customer comes to me and says that I want to change the address, I want to change the number or anything. So in that case, I would have to update that value. That is what I mean by updating the database. Creating, updating, and then you have something called as, what you can do is you can save the changes that you made, right? Here, for example, if you're using any Word file, or any Microsoft file, when you're closing it, it will ask you if you want to save the changes that you made to that file. Similarly, like that. So, if you have made any change, you can save the changes or you can undo the change or roll back the change, right? That is something you can do. What else you can do? You can also decide whether you want to give access to people to your databases. Okay, whether you want to give people the access to read or write. What does it mean by read and write? If you use these Google Sheets or anything, when you click on this share, you have this option of giving access. A general access you are giving to people, but what kind of access? Either they can be only the viewer and they cannot edit this file, either they can only comment on the file or they can edit. So in SQL also you have these two, viewer and editor. Let's say this is the database. Some people can only look at the database and understand what are the values. They can just write basic queries to look at the table. Okay, so they'll be able to only look at the table, but they won't be able to make a change. For example, if they want to make change the customer ID of this, they won't be able to do that. So that depends on the access that you give them. Okay, so giving access to the databases, that is also possible using SQL. And then the most important part is extraction of information from the database. Okay, now this extraction of information, this is the most important part in case we are working as data analysts or not data engineers, data analysts, data scientists. Yes, for data engineers sometimes, but their jobs involve a lot of other things as well. These can be considered as uses of databases, uses of SQL. And what did I say? Based on the use of SQL, it is being divided into further parts. So, creation of database, What is this part called? When you whatever queries you use for creating databases, it's called as DDL, that is data definition language. For updating the database, it's called as DML, data manipulation language. All are SQL queries only. Just each query is divided into different parts like these based on the uses of SQL. Then you have TCL. This is called as transaction control language. If you ever see a lot of job roles, they would mention the use of transactional SQL. Have you used transactional SQL? So here transaction, when they are talking about adding values to the database, removing values from a database, okay, or updating any value in that database. These are called as transactions. Let's say, like I mentioned, if a customer is there whose contact information they want to change, okay, email ID maybe they want to change. If you are changing that, that is a part of transaction. If there is a new customer being added to your database, that is a transaction. If a customer is removed, that is again a transaction. So transactional control language, there are different keywords for that. And then you have DCL, data control language. Who do you give access to the data? Whether they can edit the data or whether they can only look at the data and try to find out the insights from it. And what we are mostly going to work is DQL, that is data query language. All these can also be divided based on the job roles. For example, these mostly they are the jobs of database architects. This is also a database architect. DCL is by database administrators. These can also be done by data engineers. Data engineers, their main role is a lot of SQL. Now you have this DQL. You will have data engineers working on these. You will have data scientists working on these, data analyst, business analyst, literally any analyst who works with the data. They would be using DQL. And these itself are a lot of queries that you have to learn for this. Okay, so we will be focusing on these because our job roles, our focused job roles are these only, right? We are not focused on being database architects, data engineers. We are here focused to be data scientists or data analysts. So SQL is very vast. There are a lot of things that you find in SQL, like I told you, all these. But we are going to learn what is required for our goal. Our goal is to be either a data analyst or a data scientist or business analyst. For any of these role, this is the SQL that is required. Okay, understanding the different types of SQL, that could be a part of your, I mean, it could be asked in the interview, so you might want to remember this. I'll probably add some notes also. You can access that and go through them. There are notes already, I think. So I'll just copy that notes and move it into this. Yeah, there are notes here. I'll add these notes to the current notes. So these are the different parts that the SQL is divided into. And we can start writing queries on these now. If you have understood all these basic terminologies that you must know. Have you understood all these?
Yes.
Okay. All right. So what we will do now, later on when we are working on it, I'll show you how to install MySQL and work on it. But for now, I'll give you this compiler. Again, the compiler is also loaded on the LMS. You can take it from there. I mean, there's a link for that. However, you can directly, for now, you can use this one. Okay, save it somewhere. I'll also send it on the group. Okay, so this is where we are going to learn to write queries. So what is there on this compiler is the database is already loaded. Okay, you will be able to see different tables in that data set. Okay, and in each table there are different columns, and we know there are different data types for each data, right? It could be string, it could be integers and all that. These are just different names given in case of SQL. In SQL, if you see char or varchar, that is the string type of database. If you see int, small int, big int, medium int, it's just the integers. Decimal, it is decimal only. Date time for time, and boolean values for true and false. Okay, so they are all just different data types here. For each column, what is the data type is mentioned over here. Here you're not seeing the actual table. To see the actual table, you will have to write the query. You cannot see the table unless and until you write the query. So we will learn how to write the queries also, but I'll tell you what this database is about. This database is about a DVD rental store. So there was a time we used to rent DVDs to watch movies or any shows or anything. So this database is from then. Okay, so there are different DVDs that you would rent to watch different movies, and for in those movies, who are the actors, who are the customers who have purchased your rented out your DVDs, when did they rent, how much payment did they make, all those things are mentioned in there in this database. Okay, so that is what you're going to work on mostly. All this database, all these tables will be related to each other. Okay, and how are they related? If you remember, we did a schema, a star schema in case of Power BI, but here this Maven Movies database is a snowflake schema. There is something called as ER diagram. When we learn that, I'll show it to you. But just to understand, this is this. This is the schema of this particular database. Each table will be divided into many further dimension tables. One dimension table will not be the end. There will be many from that. Okay, so if you look at the customer table doesn't stop there. From the customer, there is an address table. From the address, there is a city table. From city, there is a country table. So each country is divided into several other, each dimension table is divided into several other dimension tables. And that is why it's a snowflake schema. So this Maven Movies database is a snowflake schema. Okay, and we are going to work on it. Now let us see what are the basic keywords that you need to know. I hope you are able to open this. Can you just try opening this and let me know if you are able to access this? Are you able to access the link? Okay, let me know if you're
Yeah,
not
it's
able.
working. It's
It's
working.
right. Yeah. Okay. So that is where you are going to write your queries. Nothing on the left to be done. Here is where we are writing our queries in this part, and this is the database. After you write your query, you will click on run here or press Control and Enter. And you don't need a Windows specific laptop for this. You, if you're using Mac, you can work. MySQL works on Macs also, so there's no need of a Windows specific laptop. Any laptop would work. So that is another reason why I'm not using this MS SQL server, because this again, it will not, an Azure SQL. Azure is just on cloud, but MS SQL server, this will not work if you are using a what do you say, a Mac, an Apple laptop. But we're using MySQL, so that'll be fine for us. Okay. Now let's start with writing the queries. So in SQL, you use very basic English keywords. Now, for example, if I ask you, um, if I want to know all the different film names, okay, let's say this is a film table, all the different film names that are available in this database. So, what column do you think I should go for? I want to know all the film names. This is the table and it has columns. So just take a guess. Which column do you think can have the film names?
Title.
Title, right? So can I say you have selected the title column, right? So select is a basic English keyword. When I select something, when I choose something, I'm going to call it as select. So I've selected the title column, and from where have I selected it? I have selected it from the film table. That's all that your query is. I have selected the title column from the film table. Now, like any English sentence, after it is completed, we give a full stop. Here we have to give a semicolon. Your query will run without semicolon, there is no problem. But then, when you write multiple queries, in that case, it becomes difficult. So, it is better to make this a habit of writing the semicolon at the end of your query when you complete your query. So, select title from fill. When I run it, I'll see all the different titles that are there in this table. Okay, all the different titles. So is there any format to write it? No. You can write the query anyway. You can write it like this also. Okay, it will still execute. Giving a comment in SQL is by using two hyphen. In Python, we used hash. Here we are using two hyphen. Select title from fill. This will help me find the column, one column if I'm looking for. If I'm looking for multiple columns, let's say I also want to see the rental rate of that particular movie, I'll give a comma, rental rate. Now how will I know what is the name of the column? I'll have to click on this problem here. I'll see all the tab column names here. From there I'll get to know. Now, is SQL case sensitive? That is, here I see rental rate is in all lowercase. If I write anything in uppercase, will it still give me the output? Yes, it will still give you the output. Wait, I did not give the space in the beginning. Okay, so it will work. It's not case sensitive. You can give it an, even though in the table it is in lowercase, you can give uppercase, and that's absolutely fine. You can write it in any way and it will work. But what you have to make sure is you have to make sure of the different spellings. Now you might, if the table name is film and you're writing films, you'll not be able to access it. What most people do is, when I say look, print the name, print the details of all the customers, print the names of all the customers. Just by reading the question, they'll mention customers, because in the question it is given as customers. You will not get an output because in the database, you should look at the table name. The table name has only customer, it does not have any S. So that is what you have to look at. So when you give only customer, you'll get the names of the customers, first name and last name. What if I want all the columns from the table? Let's say this is the customers table and I want all the columns. So should I be writing all the column names? Customer ID, first name, last name, store ID, email, and that will take a lot of time to write. Instead of that, if you want all the columns from the table, select star from customer. What will that star do? Star will help me get all the columns from that given table. Okay, so can you both try this? Give me all the details from the actors table. Print all the columns from actor table. Can you give me the query for this? I want all the columns. Write the query there and execute and see if that's working. Let me know once you're able to write it. Print all the columns from the actor table.
Done.
Done? Right. Similarly, why don't you also write? Okay, so I'm guessing this is your query, right? All the data of all the actors table, all the actors,
Yes.
right? Now, what do I want? Print the customer ID, staff ID, and amount paid by customers. Look in which table do you have all this data? I want you to explore now. I'll not give you the table name. In which table do you have all this information? And I want only these three values from that. These three columns from that, sorry. From which table?
Payment.
Yes, payment table. So did you get the output?
Just give me 1 minute.
Okay.
Done.
Done. Okay.
Yes.
Now, can you try this as well? Can you print the names of staff members working at each store or working at the stores? So look at what table will get you the names of the staff members. I need the names of the staff members, not the IDs, just the names. Is there any table which gives you that?
Staff table.
Staff
But
table.
it gives me only two output.
Yes, because there are only two staff members in that. Okay, so if you see, because there are only two staff members working in it, you have only two output. Okay, so we'll stop at this today. Okay, you can explore this database if you have some time. However, from tomorrow, we will start with some more queries. There are some more keywords and operators and everything. We will start with where tomorrow.
Okay, no problem. Thank
Okay,
you.
all right, then.
Allah.
See you tomorrow in office.